Hi everyone, and welcome to the Unit 9 Part 5 note video, Part 5. So we're on to Part 5 today of Unit 9. And so this is going to be very similar to Part 4. We have now, Part 2 and 3, we were talking about surface area of prisms and cylinders and cones and pyramids. And then starting with Part 4, we started talking about volume of those same things. In Part 4, we talked about prisms and cylinders. Today, we're going to talk about volume of pyramids and cones. Now, remember, the difference between pyramids and cones compared to prisms and cylinders is that prisms and cylinders have two bases and rectangular walls that join the two bases. For pyramids and cones, as you can see in pictures down here, they have one base and then like a point or a tip of the pyramid or cone that is opposite of that base, right? And so basically what we're going to do today is very similar to what we did in Part 4, but the formula for volume of pyramids and cones gets a little bit adjusted compared to the formula for volume of prisms and cylinders. And so here's what it is. Our volume for pyramids and cones is going to be area of the base times the height of the pyramid or cone divided by 3. So big B times H divided by 3. Remember, for prisms and cylinders, it was just the B times H part. We didn't have to divide it by anything. Again, that's the difference moving into today. We're still going to find B and H, but then once we multiply them together, we divide by 3 to get the total volume. So let's give that a shot. Now, in number 1, notice this first direction, assume equilateral base. Here's why. The base down here is a triangle, and this is a pyramid, so this is a triangular pyramid, right? Triangular pyramid. And so what we have to do in this section is just like what we did in Part 4. We need to find the area of the base. We need to find the height. So let's start with big B, area of the base. And so remember, our triangle down here is our base, and so it's going to be something like this, right? And it says assume equilateral base. And what that means is all 3 sides are the same. So if that's 14, this is 14, and that's 14. And that's huge, right? We need to know that. And here's why. Remember, for big B, it's the area of the base. And so big B changes depending on what shape the base is. For this one, it's a triangle. So area of a triangle is going to be base times height divided by 2. Now, let's say we do have a base, right? Let's call it like this, 14. What we don't have is a height. What we don't have is a height. And I'm going to draw this picture a little bit differently, right? I'm going to just kind of switch it. And so it's going to kind of look like this now. And it'll make a little bit more sense, I think. So if we call all these 14, remember, and we just said this 14 on the bottom, we can call that our base. Then remember, this is what the height looks like of a triangle. And so we need to find that H. Remember, it cuts our bottom base in half, so each side here will be 7. And then we can focus on like half of it. It's a right triangle, and so we can do H squared plus 7 squared equals 14 squared. Now, we need to do this to figure out what H is, so let's keep going. H squared plus, and 7 squared is 49, and that'll equal, and 14 squared is 196. So then we will subtract 49 from both sides, and we'll get H squared equals, and 196 minus 49 is 147. And then finally, we'll take the square root of both sides, and we'll get H equals, and I'll even do that with you, square root of 147, second square root, 147. And it tells us 12.1. 12.1 is what H is. Now, remember, we had to do all of that simply still to just find the area of our base, big B, right? But now we are ready to make that calculation. So we'll go back to red. And so the area of this base will be little b, right, which is 14. So 14 times H, which we just found, is 12.1, and then divided by 2. And 14 times 12.1 divided by 2 is 84.9 when rounded. Now, remember, that is big B, right? That's big B. So we've got big B up here now. Now we need to find H. And H is going to be a vertical height. So not the slant height this time. We do not need the slant height this time. So come take a look at this picture. See this 18? And see how the line telling us that is 18 is straight up and down? That's perfect. That's vertical. And so that is actually our h right there. We don't have to do any more work to find it. And so we are ready. We have big B down here, 84.9, and we have h, which is 18. And so the volume of this triangular pyramid is going to be 84.9 times 18 divided by 3. Do not forget the divided by 3. So let's go to our calculator. 84.9, 0.9 times 18 equals, and then remember, divide by 3, and we get 509.4. 509.4. 509.4. And then the units are going to be inches, and just like yesterday, for volume, they are cubic inches, so inches to the third power. And that's the volume. Excellent. Let's go down to the cone. Here we go. So in a cone, remember it's important because we always need to know bases. So the area or the base for a cone is going to be a circle. And so I'm going to draw that circle. And as you can see, right, it's this circle right here. So the radius is 6. So for big B, right, area of the base, for a circle, that is pi r squared. And right, our radius is 6, so that's good. Let's plug that in, and we have big B. Pi times 6 squared, and that equals pi times 6 squared is 113.1. Now, that's big B. So now we just need h, and then it's b times h divided by 3, right? But here's the problem. See this 8? That is this distance. Notice that is the slanted side of the cone. So that is the slant height. We need the regular height. We need the straight up and down height. This new green dash line I drew in there. That is our straight up and down height. So again, we are going to need that for our h. Our h is not the slant height for volume. Remember, slant height is L, and we're not working with L, we're working with h. And so with h, we need the vertical height, straight up and down. Now, notice, when I draw that in there, that makes a right triangle, right? And then across from the 90 is our C, that's where 8 is, and so we can figure out the h by doing h squared plus 6 squared equals 8 squared. And so let's figure that out. H squared plus 36 equals 64. We'll subtract 36 from both sides, so h squared equals 28. And we just got to take the square root of that. And so our h in this problem is the square root of 28, which is roughly 5.3. Now, this is our h, and I should have done it as a capital H. It is big H, right? And so the volume is again going to be big B times big H divided by 3. And so in this problem, big B we found over here, area of our circle, that's 113.1. Our h we just found over here with the Pythagorean theorem, that's 5.3. And then remember to divide by 3. And so our final answer, I'll go type it in with you, 113.1 times 5.3 equals, and then divide by 3, and we get 199.8. 199.8. And let's look at the units. They are inches, not inches, inches to the third power, inches cubed. There we go. All right, let's keep it up. So on this next one, this is a pyramid, right? We can see that because of the tip on top. And let's look at the base. The base is this rectangle thing down here, but since both sides are 12, right, they're the same, it's actually a square. So this is a square pyramid. And so remember, we need, for volume, big B times H. So let's figure out big B. That's the area of the base. The base is just a square, right? And so dimensions are 12 times 12. For a square, area will be base times height. And again, in this picture, that is just 12 times 12. And 12 times 12 is 144. So big B is 144 in this picture. Now, let's come over here and look at this 16. Notice again that this 16 is the slanted side. And so we have to do some work here because we don't want the slant height. We need the H that is straight up and down, right? We need this red dotted line. That's our H. Now, when I do that, it's starting to form a triangle with my slanted 16. The other thing I need to add to fully make the triangle is this piece. Now notice that piece is starting from kind of like the center of my square and going to the side. So that's going to be half of a side length. So if the side is 12, that little piece is 6, right? And I can pull this triangle out. I'll draw it over here. So here's the H we want. This little side is half of our side, that is 6. And then the slanted side, our slant height is 16. And so here's the 90. 16 is going to be our C. And we can do H squared plus 6 squared equals 16 squared to solve for H again. So let's do it. H squared plus, and 6 squared is 36, and 16 squared is 256. So then subtract your 36 from both sides, and we get H squared equals 220. And then we will take the square root of that to get what H is, and the square root of 220 is 14.8. All right, so we are good to go once again. We now have, after that calculation, our H, and we already had our big B over here, and that's all we need, because remember, volume is big B times H divided by 3 for a pyramid, divided by 3. So in this problem, big B is 144. We'll times it by the H we just found, which is 14.8, and then we will divide it by 3. And our final answer will be 144 times 14.8 equals, and then divide by 3, don't forget, 710.4. 710.4. Wait, did I read that right? 710.4. Perfect. 710.4 looks like centimeters cubed. And that's the volume. All right, awesome job. We got 2 more problems left, I believe, and they are the working backward problems. So here we go. We're going to use the measurement to solve for x. Notice x is the radius of my circle, and remember the circle is the base of my cone, which is the shape I'm working with here. So remember, we're going to have to work backwards out of a formula. So let's remember a couple things. Obviously, we need the area of our base. Our base is a circle with a radius of x. And so big B, remember, is pi r squared. But now if we can consider x our r, we can write that as pi times x squared. Now, one thing that's nice is we are actually given our regular h, right? That's the straight up and down distance of this cone. So we have h, we don't have to worry about that. And so let's talk about the volume equation. Volume is going to be big B times h divided by 3. Now they tell us the volume here, so we can plug that number in for V. Now we wrote big B. We don't have a number for it, but we have an expression for it. So we can replace B with that, and that'll allow us to solve for x. And then the last thing is we'll want to put this number 13 in for h, right? And so in total, when we plug these in, it'll look like this. 2,614, which is our volume, is going to equal pi times x squared times 13 for our h divided by 3. Now, we've done problems like this a whole bunch, although it can still always feel a little complicated. 2 things we want to do at this step right here. Let's combine pi and 13 into one number, and let's also times both sides by 3 so we can get rid of this fraction. So the 3's will cancel, and this will equal, and so 13 times pi is one number we're going to need. 13 times pi. So 13 times pi becomes 40.8. So 40.8. And that's the 13 and the pi. So the x squared is still there. And then the next thing we need to do is times 2,614 by 3. 2,614 times 3. And that'll give us 7,842. 7,842. So in a second, we'll divide by 40.8 and then we'll square root. But we'll have to get to that in the next video. Thank you very much. See you in a bit.